342A. The region of Bryansk was a void of winter darkness, a landscape frozen in time where the only signs of life were the rhythmic rotations of long-range surveillance arrays. At this hour, the human mind is at its slowest, but the machines are supposed to be vigilant. Within the dimly lit confines of a regional early warning hub, the first anomaly appeared. It was not a thunderous approach or a high-altitude signature. It was a whisper on the screen. Radar cross-sections barely registered above the background noise of the snowy terrain. Operators stared at flickering pulses, low-speed targets, extremely low altitude, hugging the contours of the Earth at less than 40 meters. Inside the Iskander maintenance zone, a high-security perimeter housing the heavy hitters of regional deterrence. The timing was a statistical nightmare. 3 heavy launchers, each a 44-ton titan of kinetic potential, were offline. They sat exposed, their protective shells retracted for routine technical validation. Fuel lines, the very veins of these machines, were connected and pressurized. Less than 30 meters away, solid rocket motors lay in temporary storage, sensitive and volatile. A single drone, constructed from non-reflective composite materials to bypass traditional X-band frequency detection, detached from its formation. It did not aim for the missiles themselves. It aimed for the support infrastructure. It plunged toward a cluster of specialized vehicles parked beside Hangar 2. The impact was not a massive explosion of a cinematic scale, but it was surgical. A compact, violent blast followed. Thermal sensors in the vicinity instantly recorded a spike exceeding 1,900 degrees Celsius. In the blink of an eye, the overpressure surge surpassed the structural tolerance of the surrounding facility. The facility did not collapse, but it bled. Within seconds, 2 vital transloader vehicles were rendered inoperable. Hydraulic pressure, the lifeblood of the launch rails, dropped from 5,600 pounds per square inches to 0 almost instantly. One Iskander launcher, caught in the mid-cycle of a diagnostic lift, was knocked out of alignment. Its heavy steel rails warped under the thermal stress, becoming useless. For 9 seconds, the heartbeat of the base faltered. Power flickered as the main grid tripped. Surveillance feeds froze into static. By the time the backup generators kicked in, the silence was replaced by the deafening roar of sirens. To the command center, this looked like a manageable tragedy, a localized strike. They did not yet realize that the 9 seconds of darkness was not an accident. It was the first domino in a global sequence of failure. 03:46 a.m. As the facilities in the north struggled to stabilize their damaged systems, the airspace over the regional hubs of Kursk and Belgorod transformed into a chaotic bloom of electronic signatures. On the screens of the defending air defense batteries, it was no longer a single whisper, it was a roar. Radar operators witnessed a sudden, massive expansion of targets spreading across multiple sectors. These were not dozens, but over 70 distinct signatures, arriving in layered formations at altitudes between 35 and 60 meters. They drifted in from varying bearings, weaving through the terrain clutter with mechanical precision. The response was immediate and doctrine-driven. Short-range interceptor batteries snapped into full combat mode. High-altitude long-range systems elevated their canisters. Within minutes, the night sky was scarred by the streaks of interceptor missiles launching into the dark. Each of these interceptors carried a price tag of approximately $140,000 to $160,000. In less than 6 minutes, more than 80% of the ready-to-fire interceptors in these sectors were gone. They were expended on targets that cost less than $700 apiece to manufacture. The airborne objects were not attack drones. They were Corvo decoys. These low-cost frames were fitted with specialized reflectors and signal emitters tuned to mimic the radar signatures of much heavier, faster, and more dangerous kinetic threats. The fire control systems programmed to prioritize the most significant threats, committed their magazines to the shadows. The steel umbrella was closing tight, exactly as the simulation predicted, while the eyes of the defenders were fixed on the decoys saturating the sky. The true threat remained invisible below the noise. Between the radar sweeps and the frantic missile launches, 18 high-precision strike drones slipped through at altitudes under 45 meters, using terrain masking and the smoke from the interceptor launches as cover. Their objective was not the launchers themselves, but the critical infrastructure that allowed them to function: fuel distribution nodes and auxiliary power units. One strike hit a secondary storage area, triggering a contained but intense thermal event that reached 2,100 degrees Celsius, effectively halting the reload cycle for 3 major missile units. To the local commanders, the high number of kills on the decoys felt like a victory. They reported that the swarm had been broken. In reality, they had not defeated the strength of the attack. They had been hollowed out from the inside. 3:57 a.m. The focus shifted further south to Rostov. By this time, the echoes of the northern strikes had reached local command. This was no longer a surprise. It was a test of readiness. Commanders at the Rostov logistics hub elevated their air defense systems to maximum sensitivity. Radar gain was pushed to its physical limits, expanding the search net to catch even the smallest signature. Every screen in the command center glowed with the confidence of a fortress that believed it could see everything. However, in the world of high-speed electronic warfare, seeing too much can be as fatal as seeing nothing at all. In less than 40 seconds, 72 airborne objects entered the Rostov sector simultaneously from 3 different directions. The altitudes were a chaotic mix, varying between 30 and 70 meters, and the speeds were intentionally inconsistent. On the radar displays, the signatures overlapped and blurred. To the human eye, it didn't look like an organized attack. It looked like environmental noise, a digital storm of ghosts. The fire control computers of the Pantsir S-1 systems, designed to track and engage roughly 24 targets at a time, were suddenly forced to process 3 times their maximum capacity. The algorithms began to fail. The software cycled through priorities, constantly dropping one track to chase another as the decoys mimicked aggressive flight patterns. Under immense pressure, operators began launching interceptors into the chaos. In under 4 minutes, more than $18 million worth of defensive missiles were expended into the empty air, chasing phantoms and signal echoes. While the decoys pulled the radar beams and the kinetic focus upward, 26 high-speed strike drones approached from the east, riding the heavy radar clutter of industrial structures and sprawling rail yards. Their target was the heart of the logistics operation. The first drone struck a pressurized fuel reservoir holding nearly 190,000 liters of solid propellant compounds. The second followed 7 seconds later, piercing the weakened structure. The resulting blast did not peak once. It cascaded. Internal temperatures surged past 3,100 degrees Celsius, igniting a chain reaction that propagated across the entire facility. Sensors recorded sustained secondary explosions for 34 consecutive minutes. Inside the hub, 4 heavy launchers were rendered non-operational as their chassis warped and their electronics melted. 6 vital transloader vehicles, the only means of reloading the missile batteries, were destroyed where they stood. The hydraulic systems, essential for precision leveling, simply vaporized. By 4:02 a.m., Rostov had stopped transmitting coherent status reports. The logistics artery feeding the southern front was effectively severed. This was not a victory of force, but a systemic failure induced by overwhelming a machine's ability to choose. Non-4 2 a.m. As the fires in the north and east continued to burn, strategic attention snapped toward Krasnodar. This sector was designed to be the definitive line of defense. Unlike the peripheral hubs, Krasnodar was anchored by one of the densest electronic warfare umbrellas in the world. The operators here believed that physics itself was on their side. To counter the looming threat, the Krasukha 4 electronic warfare systems were pushed to extreme output levels, flooding the radio frequency spectrum with wideband interference. Signal density within the sector spiked by nearly 60% in less than 60 seconds. Global positioning system reception collapsed across a 45-kilometer radius. To the crews on the ground, it felt as though they were sealing the battlefield inside an impenetrable, invisible wall. However, the intensity of the jamming began to suffocate the very sensors it was meant to protect. The S-400 radar arrays struggled to separate legitimate returns from the massive volume of their own reflected noise. Track confidence, the mathematical probability that a target is real, dropped sharply. Fire control systems, blinded by their own defense, began to hesitate. The fortress was no longer silent. It was screaming so loudly that it could no longer hear the enemy. Into this wall of noise came 31 low observable drones. These units were constructed almost entirely from advanced composite materials, reducing their metal content to near zero and their radar signatures to less than 0.01 square meters. Instead of fighting the interference, the drones leaned into it. They utilized passive guidance systems that did not require a signal of their own. Instead, they homed in on the Krasukha's emissions. The strongest jamming signal became a lighthouse, guiding the predators directly to the source. At 4:04 a.m., the first drone crossed the perimeter undetected. Within seconds, a series of precise impacts followed. 3 Iskander M launchers were struck while parked in a standby formation. Thermal sensors recorded localized spikes exceeding 2,800 degrees Celsius as hydraulic reservoirs ignited and control electronics failed simultaneously. Nearby missile-handling vehicles were consumed by the heat, disabling 5 more transloaders in less than a minute. For 11 full minutes, Krasnodar went dark on the regional command map. The electronic shield had become an electronic blindfold, proving that in modern warfare, the strongest defense can become the ultimate vulnerability. To understand how a multi-billion-dollar defense network can be dismantled in 30 minutes, we must look past the smoke and into the logic of the machine. The primary weapon in this simulation was not a single missile, but the architecture of the swarm itself. Traditional aerial threats rely on a centralized command structure, a pilot in a cockpit or a remote operator connected via satellite link. This creates a gravity point, a single link that can be jammed or severed. The swarm operates on a fundamentally different principle: decentralization. The drones utilized in this scenario are governed by an algorithm known as stigmergy, a form of collective intelligence observed in social insects like ants or bees. Each unit in the swarm does not need to know the entire mission profile. Instead, it follows a simple set of local rules. Maintain distance from neighbors, match the average velocity of the group, and move toward the designated objective. When the lead drone is intercepted, the remaining units do not falter. The network automatically reconfigures. The swarm heals its formation in real time, distributing the processing load across every remaining node. Furthermore, the hardware is a masterclass in thermal and electromagnetic management. By using carbon fiber composites and specialized resins, the airframes achieve a radar cross-section comparable to a small bird. Their propulsion systems are tuned for low acoustic signatures and minimal heat output, making them nearly invisible to infrared seekers until the final seconds of engagement. When coupled with passive guidance, the ability to home in on the defensive radar's own energy, the weapon turns the defender's strength into its greatest liability. In this paradigm, The battle is no longer a contest of steel versus steel, but algorithm versus procedure. The swarm does not seek to outgun
Systems
the
are being
defender.
overwhelmed.
It seeks to outthink the logic of the defense system, exploiting the inherent delays in human and machine decision-making. Beyond the failure of sensors and the ignition of propellants lies a deeper, more fragile vulnerability: the human element. In the doctrine of high-intensity conflict, victory is often measured in milliseconds, yet the human brain requires seconds to process the unthinkable. Throughout this 30-minute simulation, the most devastating weapon was not the drone or the missile, but the command and control latency, the fatal pause between the moment a threat is recognized and the moment a finger pulls the trigger. In the initial moments at Bryansk, there was a window of precisely 9 seconds. 9 seconds where the radar returns were clear, the signatures were confirmed as hostile, and the defensive batteries were energized. In those 9 seconds, the course of the engagement could have been altered. However, the culture of the defending force relied on a vertical, rigid hierarchy. Trakthu operators, at the tactical level, were trained to follow protocol, not to improvise. They did not have the authority to engage an unidentified target without verification from a higher echelon command center located hundreds of kilometers away. While the algorithms of the swarm were making thousands of autonomous decisions per second, the human defenders were trapped in a loop of bureaucratic hesitation. They waited for confirmation. They waited for a superior to take the burden of responsibility. They waited, and in that silence, the drones completed their terminal dive. This is the hierarchy trap, a psychological state where the fear of making a wrong decision leads to the inability to make any decision at all. Inside the bunkers, the air grew heavy with the smell of ozone and the sound of unanswered radio calls. The soldiers were not lacking in courage or skill. They were simply outpaced by a reality that moved faster than their chain of command allowed. When the smoke finally cleared, the heaviest cost was not the billions of dollars in lost hardware. It was the realization that in the age of autonomous warfare, a rigid mind is a liability that no amount of steel can protect. The 9 seconds of silence at Bryansk was not just a technical glitch. It was a testament to the fact that when the machine takes the lead, the human heart often finds itself one step behind. 4:25 a.m. As the first light of dawn began to touch the horizon, the map of the regional defense network no longer resembled a functioning system. In just 30 minutes, the strategic balance had been forcibly recalibrated. The numbers produced by the simulation are unforgiving. Across 5 critical sectors, between 11 and 13 heavy missile launchers were confirmed as non-operational. Even more devastating was the loss of 17 transloader vehicles, the specialized, high-capacity cranes and transport units required to reload the batteries. Without these vehicles, the remaining launchers were reduced to single-shot assets, unable to sustain a prolonged engagement. The financial assessment began to circulate through command channels almost immediately. Conservative estimates place the direct hardware losses between $2.6 and $3.1 billion. However, the economic asymmetry tells a much darker story. The defending force had expended hundreds of high-value interceptors and thousands of rounds of autocannon ammunition. In contrast, the attacking force relied primarily on low-cost airframes, mass-produced decoys, and a limited number of precision kinetic weapons. This imbalance reshaped the exchange ratio beyond any prior strategic anticipation. More damaging than the material loss was the operational pause. The rhythm of the campaign was shattered. Missile brigades that had been prepared for sustained strikes were forced offline, their logistics arteries severed. Power grids were intermittent, and command and control nodes struggled to re-establish clean data links across the fractured network. For several hours, The long-range strike capacity across the entire southern and western sectors was effectively neutralized. This was not achieved by a massive, overwhelming force, but by the precise sequencing of disruption. Each strike hit a different layer of the system: maintenance, refueling, logistics, and electronic defense. The smoke rising over the facilities was a signal to the world that the era of the untouchable fortress had ended. The damage wasn't just what burned on the ground. It was the total cessation of movement in the background. 5:15 a.m. The sun had not yet risen over Western Europe, but in the darkened situation rooms of global powers, the world had already changed. Space-based infrared sensors had flagged the thermal blooms across 5 distinct regions within 30 minutes, a signature of catastrophic systemic failure. As the data filtered through the classified networks of NATO, the Pentagon, and Eastern Command centers, the realization began to set in. The old doctrines of deterrence were dead. This was not just a regional skirmish. It was a demonstration of a new era of strategic transparency, where no fortress, no matter how deeply layered, could remain hidden or protected. The shockwaves immediately rippled through the global financial markets. Stocks in traditional heavy defense contractors saw unprecedented volatility as analysts scrambled to reconcile the multi-billion-dollar losses with the low-cost nature of the attack. Conversely, technology firms specializing in autonomous systems and decentralized processing saw a sharp spike in projected value. The economic logic of war had flipped. When a $1,000 drone can neutralize a $100 million missile battery, the entire foundation of military spending and national security must be rebuilt from the ground up. Across the globe, military planners began to shred their existing models of anti-access divided by area denial. The assumption that density equals security had been proven false. In the halls of power, the debate shifted from "how much steel do we have?" to "how fast is our algorithm?" This event signaled the start of a new, silent arms race, not for bigger warheads, but for better coordination and faster processing speeds. The geopolitics of the future will not be defined by who possesses the largest territory, but by who understands the rhythm of signals and the fragility of systems. The smoke over the regional hubs was visible to satellites, but the message was heard in every capital. In 30 minutes, the world had transitioned from the age of mass to the age of precision, and there was no going back. The smoke has cleared, but the silence that remains is heavier than the sound of the explosions. In just 30 minutes, a strategic architecture built over decades lost its rhythm. This simulation was not a demonstration of overwhelming force, but a masterclass in the mastery of timing, signals, and the exploitation of predictable procedures. Steel was not defeated by more steel. It was outpaced by coordination. The lesson of this 30-minute collapse is clear. Modern conflict is no longer decided by who has the largest arsenal, but by who understands the vulnerabilities of the system better. The failure of the defense network was not due to a lack of technology, but a failure of the philosophy behind it. Systems built on hierarchy, centralized control, and the assumption of total awareness are inherently fragile when faced with the chaotic, decentralized logic of the swarm. When every node is a target and every sensor is overwhelmed, the machine stops moving and the logistics freeze. The most important damage wasn't what burned on the ground. It was the total loss of the operational tempo. The attackers did not rewrite the rules of war. They simply exposed them. They showed that the era of traditional deterrence, based on the accumulation of massive kinetic platforms, is being replaced by an era of algorithmic saturation. So, here is the question that remains for the future. If low-cost, mass-produced systems can dismantle billion-dollar arsenals this fast, what does security even look like tomorrow? And if this entire collapse can happen in just 30 minutes, how many of our current strategic assumptions are still standing simply because they haven't been tested yet? The map has changed. The rules have shifted. And the countdown to the next evolution of warfare has already begun. The content of this video and its script were generated using artificial intelligence simulations for theoretical, analytical, and entertainment purposes. The scenarios, technical outcomes, and geopolitical data presented are part of a what-if strategic study and may not reflect 100% accurate real-world intelligence or future events. This is a simulated model designed to explore tactical possibilities and is not an official report or a factual prediction. Thank you for watching.